Hello everybody, Wirewas here. Welcome to the first official devlog for BraneScript 2.0. If you followed my videos in the past, you will be aware that BraneScript is the scripting system that I'm making for my engine, Brane Engine. I've already made a couple of attempts at this. My last one was over the course of 8 months. Even though I put a lot of work into that and I got it pretty far, I eventually ran into a brick wall with the way that I was handling references and pointers really was not good. It would have taken refactoring the entire language, which is what I started to do before stopping working on it, before I could actually get that to a usable place. Anyway, it's been roughly 2 years since I've been consistently working on that project. So at this point, it's just easier to start over from scratch. Also, in those 2 years, I have matured a lot as a developer. So I have some ideas both for the engine and scripting language side that completely changes how I want to build everything. So we're starting from scratch again. I think the biggest thing is that I realized that I don't think pure entity component systems are the best thing to use for a VR focused game engine. Like, they work great for like an RTS battle simulation or just anything where you have a lot of the same thing. But VR is unique where you have a lot of very unique things where it's like one instance of this, one instance of that, and ECS just, it puts a lot of friction on that. So I think I'm still going to use ECS for a lot of the core architecture of the engine, but kind of abstract that away behind other stuff and just use it for performance increases, but not it be the exposed scripting system of the engine. I also think I can innovate on scripting languages themselves. Change programming as we know it. One big thing that I really wanted to do with Brane Engine was make sure that everything was multi-threaded and asynchronous from the get-go. With like downloading stuff down from the server, with the eventual goal of open world environments. I really want to, from the get-go, make sure that our architecture and how it is allows us to squeeze every little bit of performance out of everything. PCs nowadays have, like, I think mine has 32 cores. And even like a Quest has at least 4 cores. So there's some room for multi-threading there, which modern game engines don't really take advantage of, at least from the core architectural level. Yes, if you have a really expensive script, you can dive in, you can multi-thread that, but it's monumental amount of effort that you have to redo for almost every script, unless you want to write your own system, but then you've written your own system and that's not provided by the game engine itself, which is what I want to do. And I want to do that from like all the way down to the syntax of the language. The way most coding languages are defined, at least how I see it, is they started with the assumption of, here's our list of instructions we want to execute. We're going to go through these one by one by one. Occasionally we might jump off into a function, execute that one by one on the same thread, and then jump back to the point of execution and then continue. And then when you add multi-threading to that, it is, here are your tools to make sure you have exclusive access to this one variable, or, you know, mutex locks and that stuff. And it's very like, very primitive and not intuitive to use for most programmers. You have to explicitly study it and try to understand it. And a lot of times, unless you have a very expensive game, it's not worth it. Higher level languages that have something like an async system, where you throw async on a function and it gets converted to a promise behind the scenes. A lot of times it's not even multi-threaded behind the scenes. It's still just the same core jumping between different functions. But even then, it's like, here's a programming language meant to be run in a synchronous way, just pretending it's still being run in a synchronous way, but we're like async on the back end. What I want to do with this version of BraneScript is try out a new concept I'm calling pipelines. Now, these pipelines are going to, for the vast majority of cases, replace functions. I still think I'm going to have a very nerfed version of functions in BraneScript, but for the most part, you're going to be using pipelines. Now, pipelines are going to act very similarly to the way that promises are represented on the compiler side of things, where you have sections of code that are executed synchronously, and then bits in between where it pauses execution, or, well, it doesn't pause, execution goes elsewhere and then comes back. And we're going to directly expose that in the language itself in a way that makes it a lot easier to understand for the coder and more ergonomic to do things in a more efficient way just by default. So I haven't fully decided on the syntax, but I think it's going to look a little bit like this. I'm definitely a little bit worried about scaring people off with a new syntax, but I think I can justify it. First thing, notice how our pipeline foo is broken into several blocks. Each one of these blocks is a different section of the pipeline, and all of the code within it runs synchronously with no breaks. Then in this break here, we insert the bar pipeline as a sub-pipeline. This is just like copying and pasting its blocks into the greater pipeline, or the pipeline equivalent to calling a function. But I think the more important part here are the lend and hold keywords. There are going to be a number of things you can do in between blocks to tell the compiler and runtime what to do between them. The hold keyword is pretty straightforward. It just tells the compiler to store these variables between the blocks, similar to how a promise works, and it will probably end up being added implicitly in a lot of cases. I still think I'm going to keep it explicit for shared objects, and for this context, a shared object is what I'm calling a thread-safe reference, similar to if in Rust you put an arc inside of a mutex, or other way around, mutex inside of an arc. The idea is that to avoid mutex locks, we're going to let pipelines specify exactly what variables they need before running, and then they wait until all of those values are ready before actually running. So you never call lock or release on a mutex. You just say all of the mutexes you need for a specific section of the pipeline. And then when you're done with that section of the pipeline, you can release it or temporarily release it. It's just a lot more ergonomic, and you're less likely to block other pipelines or cause mutex locks because all of this is going to be handled by the runtime in the background. Which brings us to our other keyword here, lend. When you say to lend a value, it's going to tell the BraneScript runtime to allow other pipelines to read or write this value while waiting for the next stage to run. So if you need something not to change, or in the case of this writable shared reference to be completely unreadable, you call the hold keyword on it. If you're fine with it changing, you lend it, and then the pipeline automatically relocks it again before calling the next stage of the pipeline. The whole point of this is to be able to very visibly describe to both the compiler and runtime what you want to be going on both when your code is running and when it isn't. And since the syntax for breaking between pipeline segments is a little verbose, you're incentivized to do as much as possible in each break. Where before, if you were using it language with async statements, it's more work to describe running multiple things at once. You just want to call async every single time you call your a function, instead of grouping them all into like an await all call. Lastly but not least, at the bottom here, we have the listen statement. While the host environment probably will be able to directly call specific pipelines, I'm predicting that the main way that they're going to end up being called is through events. Here I have it, so there's a bit of an unnamed pipeline. It's taking the little bits of pieces from the event and filling in what the foo pipeline needs to run. So there's little extra arguments. The other thing I'm planning to do in the very long term is create a node scripting system that's completely interchangeable with the text version of BraneScript, to the point where you could change nodes on one side and live update see the text change, and vice versa, with the goal being that for all of your like small algorithm stuff you use the text representation, but for more like larger pipeline and scheduling things where nodes make more visible sense just to your brain, like you can see the flow of execution much easier in nodes. You do all of that on the node side, and then long term, I would love to have like a VR native editor that has like nodes. You click one of the nodes and like the text pops up. I have like a keyboard harness that I've used with the Apple Vision Pro, so it just anyway. But that's very, very long term. For now, I'm just focusing on things like the syntax of the pipelines. You may have noticed if you look super close that I put the way I do function calls is that the arguments are on the left side of the function and return arguments are on the right. That's a little bit similar to how nodes work. So it's already kind of seeping into the syntax of the language to eventually be closer to a node system, but in text form, if that makes sense at all. Okay, so that's a fair amount of talking about like what it might look like, but what does it look like right now, and what is my actual timeline for getting all of this done? Well, I just broke ground on the repo earlier this week, so I haven't gotten much further than restarting the main branch, pushing off the old version onto like an old legacy branch, and also trying out a new parser called Tracer, which is so much better than any other parser that I've tried so far. It's amazing. It's going to be so fun to work with. If you're interested to see me work live, I have been trying to stream nearly every single day. I was originally streaming in the mornings, but it turns out none of my family members are a fan of that. So we're switching to the afternoons. I'm going to be trying to start at 1 a.m. EST, and no, not 1 a.m., 1 p.m. EST, and then go to like 5, 6-ish. I'm going to stream whenever I can. I do have other stuff that might come up, but I'm going to try to do every single day here. My excuse, this time at least, is that I'm based out of Florida, specifically the Tampa area. So we were directly in the path of the last hurricane, and we lost power for like 2.5 weeks. And then even after power came back, I was still pretty busy cutting down trees and whatnot. Which was pretty fun. Though to be fair, I have been busy with a couple other projects as well. YouTube isn't able to pay for rent yet, so I'm spending about 50% of my time or more working on other things that do occasionally pay me. But if you do want to get me closer to my goal in 6 months of being able to run all this sustainably off of some income from actually this, I do have a Patreon linked in the description below, which eventually, in hopefully 3 months, 4 months time, when I have the game engine to the point where, I guess it's not an engine, it's a framework. I'm trying to stop saying game engine. Anyway, when eventually I do get that to the point where I need to do playtests, that's probably going to be a smaller playtest with patrons first before doing a larger like open playtest sort of things for just everything I work on, because I'm planning to do iterative, smaller ramping demos. So if you want to get first access to all of that, that's there. I'm also potentially going to be putting stream replays there too. I'm undecided on that because I have just posted them on YouTube before, but that's a decision for me on another day. But anyway, timelines. I've set for myself the very ambitious goal to bring Brain Engine to next year's MIT Reality Hack, which at time of recording is almost exactly 3 months away. So that's in January in Boston. Amazing event. If you can make it, definitely do. But I'm going to try to get just this custom scripting language barely to the point, and also the game engine barely to the point where I can just throw something together while I'm there. And then show it off and have a lot of fun talking about how it's not working. So yes, very much unlike my last 8-month plus journeys making languages and engines and trying to make it perfect. This time we're blitzkrieging it a little bit. I definitely am going to spend some time refactoring after the fact. Since this is my own thing and I don't actually have any customers relying on me, I actually do have the space to refactor things after the fact, as long as I'm producing fun content about it, which I very much am planning to do. But yeah, given that deadline, let's go over the architecture plan that I currently have for the whole thing. I'll leave a link to this page in the description. I've been using GitHub Pages to host most of the spec that I've written so far. But yeah, let's just take a look at this. But yeah, here's what I have so far. It's just a simple mermaid diagram, starting over here at the bottom, which I wish I could figure out a way to show this at the top, but yeah, automatic layout graphs be like this sometimes. Start it with both the code and node editors. You can see I have a bunch of like lines going between different things. Basically, all of this is saying that all of the representations eventually boil down to the code config files. So basically, my idea is that everything important for the language, even if you are using a node editor, it still stores it in the code side of things. My reasoning behind this is it's a lot easier to get diff text than it is anything else. So keep everything human readable, even if you're using a GUI tool. Then from the code config, we go into the build system. So I've switched from Antler in my last project to now TreeSitter. TreeSitter is a tool by GitHub that they've written. It's a parser, lexer, all that good stuff. Its main feature that seems really cool is it can do incremental changes to files. So it's meant to have the ability to be able to run continuously in the background for linting features and error checking as you're coding in your file, which, given my previous experience writing an intelligence plugin for the previous version of BraneScript, that's going to be very fun to work with and probably help out a fair amount there. But yeah, after we run it through TreeSitter, it goes through a validator. So that's just like your static type checking and whatnot. And then this is one portion that we're going to have to leave off until later, which is I want to translate from intermediate representation we have here to then translate that into LLVM-IR, and then throw it through the LLVM optimizer, and then write a custom LLVM backend that then translates that back into our intermediate representation, which in this diagram I have it as a being output to a bitcode module. For reality hack, that's not what we're going to do. I'm going to commit a sin. We're going to store the AST in JSON. The idea is just a human-readable tree-based bitcode or intermediate representation is going to be a lot easier to work with and dev, especially since I want to store really good debug information and have stepped through debugging from the beginning. So I don't want to spend the time and effort it would take to create a serializer for this when I get the same representation with JSON. It's just going to be significantly less efficient data space wise and potentially parsing wise. But for what I need it for now, that's probably going to be fine. But yeah, then we like store or transport. This is kind of all in the same. Basically, there's a clean break here in the pipeline where you can go store it or you can use it immediately. Then we throw it into the BraneScript runtime, which again, bitcode module should probably just be like BraneScript or BS module. We can then transfer that to the LLVM-IR. So going back up to the top here, we could just move the IR translation stage from here to also to the validator. After the validator stage to be able to do optimization ahead of time. But for now, we're just going to use that only for actually loading it into the runtime. To load it into LLVM, we potentially run the LLVM optimizer on the client device. This is like probably going to be a toggleable setting of like how much do you want to locally optimize stuff depending on how much overhead your computer has to run something expensive at first to then potentially over a longer period of time save a lot of computation. So yeah, potentially optimize stuff. It's just a couple of function calls. It's pretty easy to turn that on or off. Then we throw this into LLVM ORC. So this is what I used for the previous version of BraneScript. Worked amazing. We just get a function pointer to whatever functions we want to call. It's if you run it through the optimizer as fast as native C. Then we do whatever linking and execution stuff. There's not enough nodes here because we also need to have all of our scheduling and async mutex magic going on in there. That kind of gives you a overview of where my brain is going at the moment. One last thing here, you'll see that from execution, I have LLDB in here. Now, I figured out how to get LLVM orc to hook into the callbacks for GDB and LLDB to register debug information when you load modules. So we will be able to do full step-through debugging of this as long as we compile with debug information and actually transmit all of that debug information as well. Excuse me here, I am losing my voice a little bit because I'm kind of one-taking this whole thing. Actually, one of the main reasons why I'm not just straight up using WASM for all of this, which I am taking a fair amount of inspiration from the WASM specification, but one of the main reasons I'm not using it is because debugging WASM code is just awful. And you don't get, you get the performance, but it's a little bit too locked down for what I need. I'm still going to lock this down a fair amount, but it's still a little bit too locked down for what I need, not completely feature complete enough. And it just has there's been no thought that has gone into the actual debuggability of this language. And for me, like, if I can't hook up a debugger and see what my variables are, I'm not going to have a fun time in that language. But yeah, that's all I really have for you so far. Hopefully, I will get another video out in the next 2 weeks, and until then, I'll see you next time. Actually, wait. Once again, a reminder that I am streaming almost every single day. And yes, I'm actually streaming every single day. I'm not just saying that. I have actually been doing that. This is actually my job now. And also I have a Patreon, which would be very nice to actually like be able to support all of this. But yes, thank you. Please like do the algorithm things. Thank you.